All right, so this one, having a supply ferrying. So we're ferrying something over the water. So it says a portion of the shoreline of an island is in the shape of the curve y equals 2 radical x. So this is kind of the shape of the island on this one edge over here. And it says a hut is located at point C here, and supplies are delivered by boat to the shoreline. So they're going to come in here and they're going to deliver supplies. And we want to find some point XY on the shoreline that's going to be delivered to minimize the overland transportation cost to point C. So we're going to, and I'm just going to draw an arbitrary point here. So we're going to say that that's some point X comma Y. Okay. And we want to know how much does the overland transportation cost? Because it costs $10 per mile to hire someone to transport the supplies from this point to this point. Okay. All right. Now we could go, at this point here, but that looks maybe even longer than if we come over here. Now, if we start going over here, it's getting even longer. So if this is drawn to scale, we want to have the shortest distance, whatever it is. Well, what do we know? Well, let's write down part one. We want our optimization. So we want to what? Well, we want to minimize overland transportation costs. So we want to minimize cost. Okay. And what is their input? Well, that's our XY coordinate. Okay. So wherever that point is for landing, that is going to be our input. So we're going to have it in terms of one of them eventually, and then we solve for the other one, and then we'll have an XY coordinate that we know that we're going to land on. Well, we know from here to here is 100. And from here, let's draw a vertical line straight down. Okay. And so that's a right angle. And then let's say we're going to also go over here somehow. Okay, so we're drawing some distance here. So we'll call that D. We don't know what it is. It's some distance. Now, do we know this distance? Well, if that's X, that means that that point is X, and it's really X comma 0. Okay, that's so we know that point. We know that point is 100 comma 0. We know that that point is x comma y. We know this distance because we can just subtract those. And so that distance is 100 minus x. So we've taken off whatever that x is, and so that's 100 minus x. Do we know this distance? Well, that's going to be y. But what do we say y is? Well, we said y is 2 radical x. And so that's 2 radical x. So whatever that x is, we plug it in here and we get this distance. Okay. Now, but the key is we have to go from shore to point C, and that's what we have to pay for. So we need to find the distance between here and here. Now, do we know a distance formula? Well, if we have point x1, y1, we have the point x2, y2, we can find the distance between those points, and let's call it d. That's going to be the square root of, now what we're going to do is we're going to take x1 minus x2, square it, add that to the distance y1 minus y2, and square it. And that's going to give us this distance. Okay, so this is the formula you might have to look up on this one. So some questions you might not know the actual formula you're going to have to do, so you'd have to look it up. What is the distance between 2 points formula? And that's what you would get. Okay. All right, so what do we want to do? We want, basically, it says to minimize the overland transportation cost. Well, the cost per mile is fixed, so that means we want to minimize D. So we want to minimize that distance, okay? Well, if we plug in the points we know into this formula, that's going to, so this is really, that's 1. So this is kind of our 2. And so 3 is where we start writing out our equation. So D is equal to the square root of, now we have our points, and we can say, well, let's be that point x minus 100 squared plus, we have y minus 0, Well, but y is what? We should probably put in what that y is, because that's 2 radical x. So that way we have everything in terms of x. 2 radical x minus 0, and that's squared. Okay. And that distance is in miles, apparently. Okay. And so what is our cost? So that's a distance, and we want to minimize the cost. Well, cost is equal to d times what? Well, times $10 per mile. Okay. Well, can we simplify that? Well, we said d was this, so we can take 10 times that. And so that's going to be x minus 100 squared plus 2 radical x minus 0, or if we just drop that, that's just going to be that squared. So we can do that and simplify it. But we start there, and so now what we can say is, if we simplify that even more, that's 10 times the square root of, and so this is going to be x squared, and then it's going to be minus 200x plus 10000, then plus, now this squared, well, 2 squared is 4, square root of x is just x, so that's going to be plus 4x. And we can simplify that as 10 the square root of x squared, and then minus 196x plus that, okay? So that's going to be our function, our, I don't know, let's call it c of x, okay? Now, this one, I don't really feel like taking and doing the whole long derivative thing, so let's just use our calculator because we know how to do that. So let's plug all that into our calculator. And I don't know what our window is going to be. Probably should be okay. So let's clear that out. And you know what? Let's just go back and put just our kind of our original point before we multiplied it all out. And then then we had x minus 100 and that squared. And then we had plus 4x. So I'm not going to go ahead and square that out because I can't remember off the top of my head what that is. So I'm just going to put that because I know I remembered that piece. And so now what we can do is we can say, well, let's see what the graph of that looks like. All right, so that means we must be way, way up here. So our window must be too low. So let's see here. Yeah, we probably need to go up to about, well, we have to go to at least 100 because that was the boat distance on the bottom for x. And let's see, how does that help us? Okay, that does that. So let's go out even further. Let's go to 150. And let's maybe go by 50. And now let's look at the graph. All right, so there we see our parabola. It's opening up, which we expect. And so it's going to be, we're going to minimize it. And that's what we want to do. We want to minimize the transportation cost. And one of the key things with these is you kind of really want to look at your graph of your function and make sure that you're at the point when you cross that 0 that it's doing what you want. You want to minimize. It's not at a point where maybe it's up here and it comes back down. Maybe it's some kind of a cubic or something, and we're at the point where we actually want to do the minimization. So it is doing what we want. So we'll go to 2. Let's go down. Let's do that as our left. We can do that as our right. And so it looks like it crosses at x is 98. All right, so that helps us. And so we'll go back up here now, and it says x is equal to 98. So we found calc the c prime of x equals 0, and we got x is 98. All right, well, what does that give us for y? Well, y is equal to 2 square root of 98. And so if we find what that is, 2 square root 98, that's 19.799. All right, so that's 19.799. You know, we could probably round that up to 19.8 if we really wanted to, but we'll leave it with that for now. And so that's our point xy. And so that gives us 98. And maybe, you know, we could put that 19.799, or you know, if we wanted to be the most exact possible, that would be the point where we would land right here on the shoreline. Okay, and then that would give us the shortest distance for that point from the shore to that point there. Okay, now that's what we found there. Now, how much does overland transportation cost? Well, now what we have to do is we have to plug in and multiply that all out. And so that's going to be C of 98. So we're plugging in the 98 here. So that's 10 times the square root of 98 squared minus 196 times 98, and then plus the 10000. And if we go back to our calculator, what we can do now is we can say, okay, well, now I want a value. I want it at 98, and that's the value it is. And it's at 198.997. And if we're going to money, we round that rounds that up, so it goes to $199. All right, so that's going to be, you know, approximately 199.00, because if we did this, that was 198.997. We round to the nearest penny, that goes up, 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 and we end up with that as our overland transportation cost when we land at the point 98 comma 2 square root of 98, or 19.799 here. Okay. All right, so that problem worked out. So let's stop there and we'll come back with more.